Okay, today we will be solving rational functions, and for rational functions we're going to use the equation fx equals x plus 2 over x to the power of 2 minus 4. So let's start by finding the vertical asymptotes. To find the vertical asymptotes we have to use the denominator, but in this case we have to factor, which is x plus 2 and x minus 2. From these two factors, we're gonna equal them. These two factors, we have to equal them to 0. So let's do x plus 2 equals to 0, which will give us x negative 2, which it's gonna be our first vertical asymptote. X equals to negative 2. And then let's do the second one, which is x minus 2 equals to 0, which will give us x up and a positive 2. So from that, that's going to be our second vertical asymptote, which is x equals to 2. Okay. Now that we got our vertical asymptotes, we can start ahead and do the domain. So let's do negative infinity, negative 2, union, negative 2, positive 2, union, positive 2 to infinity. As soon as we got our domain and our vertical asymptotes, we can start graphing it. So our first vertical asymptote is negative 2, which is one right here. And then positive 2, which will be right here. Okay. Now we can start finding the horizontal asymptotes. To find the horizontal asymptotes, we have to remember that we have to use Bobo, 14, and 8 DC. And let's remember that Bobo stands for big on bottom equals to 0, but T stands for bigger on top, none, and each DC stands for exponents are all the same, divide coefficient. And for this situation, we will be doing, the reason that is Bobo is because the exponent is bigger on the bottom, which is, it will give us 0. So the horizontal asymptote has to be y equals to 0. Okay, so now that we got our horizontal asymptotes, we can look for what are our x-intercept. To find our x-intercept, we have to equal the numerator to 0. So basically it will be x plus 2 equals to 0. And then solve. So it will be x equals negative 2. So that's going to be our x-intercept, negative 2, 0. Now for this one, you actually put the coordinates because you're looking for the x-intercept. But as said before, if you were looking for the vertical asymptotes, it's just basically like the lines that you're putting in the graph. So to see where the graph will be separated. Okay, moving on. Now let's find the y-intercept. For y-intercept, you just have to plug in 0 for every x there is in the equation or the function. So 0 plus 2 over 0 squared to the power of 2 minus 4. So this will end up giving us 2 negative 4. And if we simplify it, it will be 1 negative 1/2. So our y-intercept will end up looking like this, 0 and negative 1/2. As soon as we got those answers, we can start plugging in the horizontal asymptotes in our graph as well. So our horizontal asymptote is in in this on 0. So that means that this is where our horizontal asymptote will be. And then our x-intercept is -2 and 0. So that will look like -2, 0. The 1 point is going to be there. And the y-intercept is 0, -1/2. So it will be like in the middle right there. Okay. Now we can start looking for our holes. For our holes, as we factored earlier, x plus 2, x to the power of 2 minus 4. We factor it to x plus 2 and x minus 2. As you can see, when you factor, there's these 2, so you have to cancel them out, which you're left with 1 and x minus 2. So this will be the remaining function. So now what you're gonna do is plug in that x-intercept, -2, to x. So it will be 1, -2 minus 2, which will give us 1 and -4. And that's in our holes will look like -2 and -1/4. So as when you plug it, so at this point you have to plug in -2 and -1/4, which will be like right here, and you get rid of this one of x of one of the vertical asymptotes, for the fact that you plug in the -2, so you get rid of this one. So you end up having one vertical asymptote, which is x equals 2. And your other vertical asymptote was not other vertical asymptote, but your hole will be -2 and -1/4, which will be right here. So you take out the x equals to -2 for the fact that your hole is at -2. So as you can see, we took it out. So now you have your hole and your y-intercept. At this point, you have to keep in mind that that your graph will eventually just go straight like that. But remember, this type of graphs have to stay near that horizontal line or the y-intercept line. They cannot go off more like all the way over here. That means that this has a multiplicity of 1, which will give us the other one that will go like that. And that's how you graph a rational function, and that's how you solve for a rational function.